네, NCT 팀의 영상 잘 보셨나요? 계속해서 JNU 랩 팀입니다. 광산환경 연동형 실시간 설비 제어 시스템 발표 이어집니다. 함께 보시죠.
Hello everybody. So Kakan PhD researcher at JNU National University, and today my presentation topic is regarding proposal for improving mine ventilation. Actually, if we talk about the mine ventilation, there are different methods in the world, and too many researchers are working on to enhance the methods which are already present for the mine ventilation. So, introduction: use of mechanical equipment, blasting and presence of numerous gases creates pollution in mines, endangering health of workforce and fire hazard. As we everybody know that due to the blasting and as well as after the blasting, when there is a process of excavation, too many heavy machinery goes in. Due to blasting, carbon monoxide, nitrogen oxide and different other oxide gases like carbon dioxide, they generate, which cause a serious trouble for the workers present inside the mine. Now, a good and effective ventilation system is necessary in workplace and has the function of emitting air contaminants such as dust, fumes and vapors. The ventilation system should be simple and cheap and effective. The only thing is that for the ventilation, there are methods which can actually give us 90% of the good result, but unfortunately they are really expensive. So what we are going to do today, that we are going to give a new idea to combine different techniques and make the method of ventilation cheap. So what problems are there actually with the simple ventilation methods? We are using ventilators and exhausts, and then we are ventilating the whole mine and tunnel, taking those gases out of the mine. So problems of the ventilation are concentration of carbon monoxide after immediate blasting. This is the blasting phase. This is a simple tunnel phase we have shown just to show the problems of present in mines and tunnels. So if you see this is a phase, and after blasting you can see the carbon monoxide appearing close to the phase. So after 15 to 13 minutes of blasting, you can see that the carbon monoxide travels from phase onwards due to these are, if you see these places here, these are the ventilators. One ventilator, two ventilator, this is a big exhaust from the outside ventilator. So the gas is traveling from the phase to outside because the new gas is being, the new air, fresh air is being thrown on the phase. So if you see, after 30 to 45 minutes, the gas actually reaches to the middle of the tunnel, and within the 45 to 73 minutes, you can see that the gas starts to disappear and starts to come out from the mine or the tunnel. So problem in this we want to share with you, that if you see these orders here, order 1, order 2, order 3, you can see that the gas is actually trapping in these pockets and in these orders, and as well as the pockets which are present inside the rock there, the gas traps there, which creates a huge trouble because we can't really remove or ventilate the mine or tunnel properly. So there are different methods there for the ventilation of mines and tunnels which are being used in present. One is a natural method, number 2 is a general method, number 3 is dilution ventilation, and number 4 is local exhaust ventilation, LEV. Let's come first for the natural ventilation. Natural movement of air entering and leaving openings such as windows, doors, roof, ventilators, as well as through cracks and trees of mine. Heat from the top of the mine to the lowest level of the mine, and they, through creating a different gradient of the temperature, they can actually create a natural ventilation system inside the mine. But the problem in that ventilation is that it doesn't do the job completely. And as well as if we are putting the shafts from the top to the bottom, for that purpose, one company or one country or one city who are doing it, they have to actually properly design the mine from the start so that the shaft will be concentrated on the middle of the mine. So all the mine will be actually connected to that shaft, because making a shaft is also expensive. So we can't really drill so many shafts into a mine. General ventilation. Ventilation aims to improve or maintain a safe quality of air in the work environment using airflow, to remove contaminants and polluted air methods, to replace them with clean air, or supply or forced ventilations which are being used as a form of ventilators, exhaust or induced ventilation. So exhaust is also being used to suck the gases and dust from the face of blasting, so that it will not really travel throughout the mine and come out from the portal. So, dilution ventilation. DV consists of general by dilution ventilation. Uncontaminated outside air is pumped in or is sucked into dilute and reduce the concentration of air. Actually, when the gases are present and there is a lot of contamination in the mine, in the air of the mine, so the new fresh air they pump inside through the ventilators to dilute that air and to finish their strongness inside the mine. So acceptable levels to which a worker can be safely exposed for 8 hours a day, they actually they keep pumping through the ventilators the fresh air inside the mine until there is a safe level is achieved. So problem in it is not these days, even in Korea, the problem in the mine is that the ventilators are actually run 24 hours every day. So by doing that, it actually consumes 50% of the energy, total energy used by the mine. So to reduce that cost, we must design some new and cheap methods which can actually reduce the overall energy usage in the mine. Local exhaust ventilation. So local exhaust ventilation aims to capture or contain contaminants at their source before they escape into the work or room environment. Like I told you that if we can suck gas or dust from the face of the generation, then it will not really travel throughout the whole mine and go out from the portal. The LEV system consists of one or more hoods, duct, air cleaner, and a fan. LEVs remove contaminants rather than just dilute them, like the simple ventilators or exhausters. Use of the natural ventilation. Actually natural ventilation is not suitable process which emit dust, fumes and mist or gas, because into the pockets and into the orbits and inside the mine, it can get stuck and we can't really, it's not completely viable. So rooms for the chemical storage, where there are rooms for the chemical storages, it can't really, natural ventilation can't really go through those rooms and stuff. Half ventilated area should be between floor level and a height of 2.25 meters from the floor if we want to use natural ventilation system. So use of the dilution ventilation. DV is usually applied to the control of contaminants in solution meeting these criteria. To control vapors from low toxicity solvents, to control contaminants released over such a large area or in such a manner that LEV is impossible or impractical or prohibitively expensive. So, for effective DV, the exhaust outlet and air supply must be so located that all the air implied in the ventilation passes through the zone of contamination, avoids re-entrance of the exhausted air. So, for the use of the dilution ventilation, large volume of the problem which are related to dilution ventilation is that we need a really too much amount of air for actually diluting a huge area. When there are huge areas and mines is too long and tunnels are too big, then we can't really, it's not viable to use the dilution ventilation system. Employer squares are difficult to control near source, means where there are near to the face, it's really hard to actually operate them there, so it's not really a good system. Use of the local exhaust ventilation system. The most effective means of controlling air contaminants is to capture and remove the air contaminants at their source with LEV and to prevent them from being carried away by air currents into the breathing zones of workers. LEV is effective in removal of toxic gases within localized sources of contaminants. LEV consists of 4 parts: hoods, ducts, air cleaner device, fan and motor. Actually, this is what we are going to actually modify, what our idea is to modify the LEV system and combining it with the water mist system. Problem ventilation. At present, many methods are being used for mine ventilation which are successful to some extent but are not completely safe or efficient. Most of the methods are expensive in the long term. Currently, 24-hour running of ventilator consumes 50% of the total energy used in the mine. Ventilators and LEV methods don't completely remove numerous gases and dust present at the working phase after blasting and during excavation when heavy machinery is being used. So, what we are going to do, we are going to modify LEV and as well as giving a really easy method to create a water mist for the catchment of dust and other foreign particles in the near the face area. So, in present, a lot of researchers have done a work. They are actually doing a work for creating a water mist through blasting in the mines, water-filled bags and with the detonating them, which creates actually a further problems because it generates even more carbon monoxide and nitrogen inside. So we have designed a really easy method to actually create a water mist which can actually cover 50 meters area if we have a strong machinery. So, if we have pipes like that, we can connect the pipes together. One is a main pipe and then a small pipe at the angle, and putting this pipe together, you can see it looks like that. And as well as if we use the air compressor, actually we need to use the air compressor. Each and every mine in Korea or all over the world, they have really strong compressors present within the mine. So we don't really need to buy a new equipment or something. We just need a compressor. After compressor, we can design this kind of piping, and we can use a water tank which can be put on a truck on a bigger scale and a big compressor. We can actually make a water mist as shown here. It's really easy and it can be really useful to do. And number 2, this is the concept of a water mist. Number 2 is actually we are changing the LEV system. We are modifying it. That front of the duct duct of the LED system, we can actually put a hood, which is a foldable hood. Okay, we can fold it up when we are after the blasting. We can open it up, and after we have been sucked all the gases and everything, then we can close it, and we can normally use the exhaust system in the one. So this shows that how to open and close. There is a the simple common hood, and here is the place where we can actually attach the duct of the LED system, and we can actually control the bigger area inside the mine, even not allowing them to pass through the area, further area. So this is the example of the hood, which is being attached with the LED duct. So these are some videos I want to share with you. This is the mist. It's an 80 psi air pressure. We can actually generate the mist really easily by using compressor and the pipe. So this is the water source. So this mist is actually quite strong. So we can actually create a big like this. We can actually create a big water inlet for the site on the near the face. We can put it on the truck with water tank, and as well as we can put one compressor, and we can generate the system really cheaply. We can actually control the dust going through all the mine. So modification area combining with the mist dust control. Actually, this is the modified idea of the controlling the dust and gases inside the mine. Purpose is to reduce cost and to enhance the air quality inside the mine in short time, so that we will not be using the ventilators and exhaust for 24 hours, which is a big trouble. Use of foldable hood, as I explained above. Use of foldable hood. Use of foldable hood here. Use a foldable hood front of the duct, which will help to extract dust and gases in short time. Attachment of a catalytic converter, which will neutralize gases such as nitrogen oxide, carbon dioxide, and carbon monoxide, etc. Use of water mist to reduce dust during excavation. Actually, these methods are really good and really cheap to use because already they are being used. But what these methods will do, it will reduce a lot of time and a lot of it will save a lot of money, because to create a water mist is really easy by the use of a compressor and a water tank, and as well as for the use of catalytic is also not so expensive, so we can actually attach it with the duct and we can neutralize the gases, and what it will do is that we will completely neutralize the gases, and the environment outside the mine will be also, it will be good for the environment. But currently we just do a ventilation and we take it out, and we actually it causes a huge hazard for the environment. So this is the concept which we are talking about. So if you see, this is the duct of the exhaust system, and this is the catalytic. Actually, what is the job of the catalytic? Catalytic job is that it actually the gases which go through it actually neutralizes them. Like carbon monoxide, it will take monoxide and carbon separately. Nitrogen oxide, it will take the oxygen and nitrogen separately. So it will be not harmful for the environment, and as well as for the workers present in it. So if you see, then there is this duct. We can actually attach this foldable hood to the duct, exhaust duct, which can actually, after blasting, it can actually take all the dust and gases through this this duct and this hood, foldable hood. After taking the gases, sucking the gases from this, extraction of the gases from this, we can actually fold it again, which will not be so that we can do the further excavation work. it's a foldable duct which has been designed foldable duct so that we can reduce the gases and everything when needed. So after it's removed, we can actually starting the excavation. Due to excavation, you know there are a lot of gases, emissions, and fumes, and as well as dust in this. So if you see this truck, there is a compressor on this truck and a water tank. Through this compressor and water tank, we can actually generate a mist, and we can reduce the dust, and we can actually not allow dust to go through the whole mine, which can solve a huge problem present in daily life at the moment in Korea. So summary and recommendations from us that the purpose is to reduce cost and to enhance the air quality inside the mine in a short time. In all the other methods, the problem is that all the gases and dust travel from the point of generation and go through the whole length of mine, which consumes more time and creates safety issues for workers there. The idea is to combine two modified